Hi, I'm gonna tell you about describing patterns, linear and nonlinear functions. My name Hugo Fernando Luque Gonzalez. Let's start. First, let me tell you about relationships. There are three ways to represent a relationship. The first, using a table, using a graph, or using an equation. Some books use another way that is a word form. It's kind of explaining either the table or the equation by words. All relationships all relationships have two types of variables: the independent variable that it's calling the domain, and the dependent variable that it's calling the range. The domain is the input independent variable, the input, which are the variables that you have first. And the range is calling the output. According to the independent variable, what is the result in the dependent variable? If each element of the domain has a relationship with one element of the range, we can say that we have a function. However, if one element of the domain it's giving you it's giving you more than one element of the range, we can call it a relationship but not a function. Now, what with patterns and linear functions? What if we have a pattern, a relationship between two variables, and we want to know if it's a linear function, if the graph is a line? You have to check the change of the dependent variable. If the change of the dependent variable is a constant, if the change of the independent variable is a constant. If the independent variable change always by 1 unit, and the dependent variable change according to this change of 1 unit by 2 units, you will have a linear function. If not, so it's not a linear function. But you can say that we have a pattern and a nonlinear function if we don't have a linear pattern but follows a rule. So we can see a rule. We can say that it's a pattern but it's not a linear function. How you can find patterns? Finding patterns, you have to identify how the independent variable changes. You have to identify how the dependent variable change, and check whether the pattern could be a linear function. Check the pattern. And now we're going to watch an example. Let me show you an example. We're going to see it with 3 tables. We have 3 tables here. And we have 2 variables. T, measure it in seconds, and X, measure it in meters. No, as we are mathematicians, we don't care about the negative sign here on time. In physics, it represents something, but we just have to take into account which is the independent variable, which is the dependent variable, and how to relate it, and if we have a linear function or not. So let me show you how it works. Let's see the first table. Which one is the input? Which one is the input first? Which one is the input? Which one is the domain? So which one is the independent? The time or the position? The time is the independent variable. Time is the independent variable. We couldn't stop time, but we can change our position. So we can see the domain, the inputs are 0, 1, 2, 3, and 4. These are the elements of the domain. And the elements of range are 0, 3, 5, 6, and 6. One element of the domain It's telling you one element of the range, so it's a function. And now we can say that we can check if it's a linear pattern or not. You can see here that the domain increases by 1 unit, and the range, we can see that here we increase 3 units, now we increase 2 units, now we increase 1 unit, now we increase by, we didn't increase it, and if I add here 5 on the domain, what will be the next value? Could you tell me the next value? Think. So if here is 3, 2, 1, 0, minus 1, so the next value will be 5. It's a linear function? No, it doesn't change using a constant. First 3, then 2, then 1, then 0, then minus 1. So it's not a linear function. It has a pattern? Yes, it has a pattern. I have to change first by 3, then 2, then 1, 0, minus 1, next minus 2, so on and so forth. Let's see the second table. Minus 5, then minus 3, minus 1, 1, and 3. So how the domain is changing? The input is changing by increasing the last number by 2. Minus 5 plus 2 minus 3 plus 2 minus 1 plus 2, 1, so on and so forth. And here, 20, 10, so I decrease by 10. 0, I decrease by 10, a constant. 10, I increase by 10, so no, I should decrease by 10. It's not a linear function. It's not a linear function. It has a pattern? Maybe yes. Maybe it could be here 10 or maybe 30. But we're going to convert this table to a linear function. We're going to convert it to a linear function. How? 20 decrease by 10, so 10, decrease another 10, 0, now we're going to decrease another 10, minus 10, another decrease by other 10, minus 20. We have now a linear function. The pattern follows a linear function. Each time I increase 2 units in the domain, I will decrease 10 units in range. Now the output decreased by 10 units. This is a linear function. And here we have minus 4, minus 3, minus 2, minus 1, 0. So we're increasing the domain by 1 unit. And let's see what happened to the range. 15, then 10, so I decrease by 5. 20, I increase by 10. 5, I decrease by 15. 25, I increase by 20. So what is the next? Here is 1. What is the next? Again, let's see. 15, decrease 5, increase 10, decrease 15, increase 20, decrease 25, 0. That will be the pattern. It's a linear function? No, it's not a linear function, but it follows a pattern. How could we know if actually we have a linear function? One way to do it is to graph the tables. Graphing the tables will show you a line. If it shows you a line, it's a linear function. If not, so it's not a linear function. We told that the first table is not a linear function. So we're going to do the graph to check. Look it. It's not a linear function. It's not a linear function. Mhm. It's not a linear function. Now the second table. We said that the second table is a linear function. Is a linear function. So when I do the graph, it should show me a line. Yes, it's a line. It's a linear function. It's a linear function. It's a linear function. And this, we said that no, that it's not. It's not a linear function. We got to prove it by a graph. Could you see it's not? Obviously, it's not a linear function. It's not a line. It's not a line. It's not a line. But we can see two ways to represent a relationship and a pattern, using a table, and using a graph. And that's how we work with patterns. This is how we can see if a pattern is a linear function or not. And this is how you can describe a pattern. Remember, describing patterns, how? Check how could you know the next number. In this case, we noticed that it was 5. In this case, we noticed that it's 2, that is 0. And here, for example, we're adding by 2, so it's 5. Here will be minus 20. We're subtracting 10, so it's minus 30. This is how linear functions are so easy, because the relationship is easy to know. You just have to increase or decrease by the same amount. And that's all. That's what I have to tell you about patterns and linear functions, nonlinear functions. Any question you have, let me know. Any hint you have, let me know. If we can improve this video, just tell me. Thank you so much.